If n choose 3 is equal to 56, show that n to the power 3 minus 3 n squared plus 2n minus 336 is equals to 0. Hence find the value of n. So this is our problem, and this is under combinations. So this is given as 56. But what know is that this one, n choose 3 is the same as n choose r, that is in the form it is in, of which this is given as n factorial over n minus r factorial r factorial. And what we know again is that n factorial is nothing but, we'll say there n, we'll multiply with a number that is less than n with 1, so it will be n minus 1. The next one will be n minus 2, n minus 3. We'll keep on going until we reach a 1. So that's when we'll stop our multiplication. So this is n factorial. Now let's simply substitute. Now here we have n choose 3, which is the same as saying n factorial over n minus 3 factorial, then 3 factorial. This is equal to 56. Okay, so while there's n factorial there on top, we can substitute with the one that we just generated, the formula for n factorial, which is equal to n times n minus 1 times n minus 2 times n minus 3. So if you don't want to go up to 1, you put a factorial there to mean that you were still expanding. Then we divide with n minus 3 factorial. 3 factorial is same as 3 times 2 times 1, which is equals to 6. This is equal to 56. I'll write it on the left. Now n minus 3 factorial, the one on top and down will cancel, leaving us with n minus 1 times n minus 2 to be equal to, being divided by 6, to be equal to 56. Now what we do next is simply cross multiplication. So this will give us n minus 1, n minus 2, which is equals to 56 times 6 gives me a 336. So when I expand, I'll get n times n to be n squared minus n. Put this under parentheses, I have multiplied by n minus 2, or equal to 336. Now this on the left can still be multiplied further, so I get n to the power 3 times 2n squared minus n squared, then this will be positive 2n. Positive 2n. Of which this is equals to 336. So we have those two other terms, so I'm going to get n to the power 3 minus 3n squared plus 2n as my answer, which is, so I'll take the 336 on the left, I remain with the 0 on the right. So we've shown this is the first part of the problem where we're taught to show that this is what we get. Now the next case is to solve what? For n, using the same answer that we have in the first part, which is like that. Now if you look at this is simply a polynomial of degree 3. So we need to see how we can simply solve it. Now here, those two terms that are in the middle, negative 3n squared and 2n squared, will be written as sums, meaning that we have to look for numbers that can simply be added to give us a negative 3n squared, and also numbers that can be added also to give us a positive 2n, so that it can be easily factorize. So this one is the same as negative 8n squared plus 5n squared. So when these two are added, will simply give us negative 3n squared. Then for 2n, we simply get negative 40n then plus 42, which when you add these two, you simply get a 2n there. Okay, So the ones that we've just presented as sums will be substituted where they're supposed to be. So it will be minus 8n squared plus 5n squared. Then we say for where there's 2n, we're going to put that on. So there is n, so it will be minus 40n plus 42n. 42n, sorry. That should be a 42n there. So we have to write plus 42n, then you say minus 336. This is giving us our answer to be 0. Now we're going to group two terms, the first two terms, and again the second two terms, and also the last two terms together. Then factorize what is common. Now in the first one we have that n squared is common, so it will be factorized. We remain with n minus 8 under parenthesis, then plus. Here in the second bracket we have 5 to be common, so remain with 5n is common, so remain with n minus 5 into 40, we have 8, then plus. The next one is 42, which is common. Then we have n inside parenthesis minus 8, or equal to 0. So what is under brackets is the same, so we'll write a single bracket for n minus 8 to multiply with the other remaining values, which is n squared plus 5n plus 42, then or equal to 0. So what this means that n minus 8 is equal to 0, or the other part, which is n squared plus 5n plus 42 is equal to 0. So when the 8 is taken the other side to get n to be equal to 8, then for this quadratic, n is not defined in a set of real numbers. So in this case, we just go for the answer that is defined, which is 8.